All right, in this video, we're going to go ahead and switch gears a little bit from what we've been talking about. We've been talking initially about moles and converting grams to moles and empirical formulas and things like that. What we're going to talk about now does relate to moles, and we're going to come back to how it relates to moles here in just a little bit. But in order to do that, we have to understand the basics of what's called a chemical equation or a chemical reaction. When a chemical reaction happens, and again, for this class, we're going to stick with basic chemical reactions. All that really happens is the atoms are going to rearrange themselves. And when they rearrange themselves, a lot of times it might make it cold or hot. You might see a color change happen. You might smell something. You might see some gas bubbles form up. There's lots of things that you might observe when a chemical reaction happens. Okay? Just like a math problem, when we show a chemical reaction, we write it like when two things react, we use a plus sign. And when instead of an equal sign, we use a little arrow here. And that arrow means that it's going to produce. And then on the right-hand side, we have the product. So this side here, these are called the reactants because they are the things that are reacting. So those are the reactants here. And on the right-hand side of the arrow are the products. Okay? And so the products are what are produced or what's formed when a chemical reaction happens. Now, when we look at a chemical equation, though, so this here is a full chemical equation. There's some things we could say about what this represents. Okay, we could say that two molecules of H2 are going to react with one molecule of O2, and that's going to produce, again, here's our to produce, two molecules of water. Okay, this G and G and G here, we're going to talk about that in a little bit, but just so you know, that stands for gases. It means that the hydrogen is in the gas state, oxygen is in the gas state, and the water is also in the gas state. Okay, sometimes you'll see a little S, that means it's in the solid state. Sometimes you'll see an L, that means it's in the liquid state. And then the final one you may see, it may say AQ, which stands for aqueous. That's a Q, sorry. Aqueous, which means it's dissolved in water. And we'll talk about those in a little bit more later on. But when you see those things in parentheses after the chemical symbol, that's what that represents. So again, let me say that again. So this means that two molecules, this whole thing right here, two molecules of hydrogen gas are going to react with one molecule of oxygen gas to produce two molecules of water in the gas form. Now you'll notice that there's a 2 here and there's a 2 here. Okay, well, why didn't I just write it without those there? Why don't I just write like this and like this? Okay, the reason is because every atom has to be accounted for in a chemical reaction. You can't lose an atom. Notice that right here we have O2. That means we have two oxygen atoms. But on this side we have H2O. That's only one oxygen atom in water. So where did that other oxygen atom go? It didn't go anywhere. We can't have lost an oxygen atom. Oh, there was two on one side and now there's only one on the other side. That can't happen. So what we have to do many, many times with chemical equations is we have to balance them. And by balancing them, let's move down here. When you talk about balancing a chemical equation, you have to obey the law of conservation of matter. Okay, sometimes it's also called the law of conservation of mass, which basically means that no matter, and therefore none of the mass, is lost or gained in a chemical reaction. Think about like when a big bundle of wood burns. Well, then all you have is the ashes left. You lost a whole bunch of mass, Mr. Johnson. No, you didn't, because most of the mass from that smoke went up, or from the wood, went up into the air as smoke. Okay, so no matter and no mass is lost in a chemical reaction. So when we write the normal equation, we'd write H2 plus O2 makes H2O. And again, these things right here at the end, those will be there. I will put them there. You don't necessarily have to. Okay, when you balance a chemical equation, though, you have to make sure that the number of atoms on both sides are equal to each other. And the way that you do that is you have to look at every single atom in the equation. For example, here, this represents H2 represents 2 hydrogen atoms. Over on this side in H2O, there are 2 hydrogen atoms. That means that the hydrogen atoms are balanced. Both hydrogen atoms from each side are present. Okay, but again, we already talked about this. Here there are 2 oxygen atoms. Here there's only 1. Okay, so the oxygens are not balanced. So in order to balance them, what you must do is you must change what are called the coefficients. And the coefficients are these numbers that can go in front of each of those chemical formulas. So since there are 2 oxygens on the left-hand side right here, there need to be 2 oxygens on the right-hand side. And again, the only thing you can change when you balance an equation are the coefficients. So I can put a 2 right there. What I can't do is I cannot put a 2 down here. Okay, that would make it H2O2, which is hydrogen peroxide, and that is not what's formed when hydrogen reacts with oxygen. But you can change the number of water molecules that are formed. So we can make 2 H2Os. Okay, now notice that now we have 2 oxygens. And again, and sometimes it might help to kind of draw these out. There's one water, and there's another water. So notice we have 2 oxygens here, and now we have our 2 oxygens here. So the oxygen atoms are balanced. But by balancing the oxygens, we also unbalance the hydrogens. Because notice now there are 4 hydrogen atoms, but on this side there's still only 2. So what do we need to do? We need to put a 2 right there. Okay? And now we can say that that equation is balanced. So when you do this, you start with the basic, what we call the skeleton equation, the equation with nothing in it. And then basically you just start going back and forth. You look at how many there are on one side, you look at how many are on the other side, and you just go back and forth until everything is balanced. I promise you, I will never give you one that can't be balanced. Because if it doesn't balance, then the chemical reaction can't happen. Every single chemical equation, if that reaction is a real reaction, has to be able to be balanced. Okay, remember, only the coefficients can change. So this is that same example I just showed you. We balance the oxygens first by putting 2 waters, and then we balance the hydrogens by putting that. All right, so there's a couple of things that might help you. Let's do a couple of examples here first, though. Okay, so example 1 says balance the following equations. So Ca plus HCl makes CaCl2 plus H2. So watch how I do this. 1 calcium, 1 calcium, 1 hydrogen, 2 hydrogens. Okay, what do I need to do? The only thing I can do is put a 2 right there. And then anytime you put a 2 in the front, that 2 goes to everything. That means there's 2 HCl's, which means there's 2 of those, which means there's 2 hydrogens and 2 chlorines. Okay, and so what does that mean? It means that there's 2 hydrogens here, and now we have 2 hydrogens here. That also means we have 2 chlorines, and hey, what do you know? We have 2 chlorines. That means that that equation is now balanced. Okay, let's go to the second example. KClO3 makes KCl plus O2. So we've got 1 potassium, 1 potassium, 1 chlorine, 1 chlorine, 3 oxygens, 2 oxygens. So you've got 3 and 2 here. So in that case, we know the smallest number that goes into both those is 6. So we need to put a 2 there. And that's going to, again, that 2 goes to everything. And then we need to put a 3 there. And notice 2 KClO3s and 3 O2s both make 6 oxygens. Okay, but I know what you're thinking. That messes up the K and the Cl. You're right. Let's put a 2 right there. And now it's balanced. Okay, the third example is going to be it's going to be number 1 up here. We'll come back to that in just a minute. So we've got, let's start with what we can do. 2 carbons, 6 hydrogens. I'm going to put a 3 right there. Again, because there's 2 H's there, that we need a 3. Okay, and now we have 2 times 2. Be very careful. That's 4 oxygens. And then we have 3 more right here. Plus 3 more oxygens equals 7 oxygens. Now the problem here is On the right-hand side, we have 7 oxygens, but on the left-hand side, it's O2. So how can you possibly have an odd number when it's O2? And the answer is you can't. Okay, you have to have an even number. And one thing that we know is that every odd number, if you double it, it will turn into an even number. So what we're going to do is we're going to go back to the very beginning, and we're going to double everything. We're going to turn that 1 into a 2. We're going to turn that 2 into a 4. And we're going to turn that 3 into a 6. And what that does is on the right-hand side now we have 14 oxygen atoms instead of 7. And so to have 14 oxygens, we put a 7 right there. And now that equation is balanced. So that's what that first one up here says. If one side has an odd number of one atom and the other side has an even number of the same atom, an easy way to solve that problem is to go back to the very beginning and double every coefficient you've already placed. And that will turn your odd number into an even number. And that's what just happened to us. Okay, and then number 2, we're going to see in this example. Okay, let me kind of erase that just to give us a little bit more room there. So Na2CO3, so again, right away, 2 sodiums. Here's 1 sodium. So I'm going to put a 2 right there. Now, the second one up here says, if a polyatomic ion is present on both sides of the equation, count the whole ion, not the individual elements. Okay, so what that means is, notice that we have CO3 here, and we also have CO3 here. And there's 3 CO3s. What does that mean? It means there's 3 carbonates. That's what CO3 is carbonate, which means I need to put a 3 right there. Okay, because now I have 3 CO3s and now I have 3 CO3s. Rather than saying 1 carbon and 3 oxygens, if CO3 is on both sides, you can keep them together like that. Okay, now that messed up our sodiums though, didn't it? So I need to fix my sodiums. So I'm going to put a 6 right there because we have 6 sodiums on the left. And now with aluminum, I have 1 aluminum here. I have 2 aluminums here. So I'm going to put a 2 right there. And notice what that does. 2 times 3 is 6 OHs. And hey, what do you know? We have 6 OHs. Okay? Now, every single one of those equations needed a little bit. But some equations don't need to be balanced at all because they'll already be balanced. So go ahead and pause the video at this point. I want you to try these next 4. And then once you've done them, go ahead and bring the video back and finish these up here with me. So the first example, 1 potassium, again, kind of follow my logic. 1 NO3, 1 NO3, 1 sodium, 1 sodium, 1 OH, 1 OH. There it is. There's an example where it's already balanced. Okay, the second example, 1 Mn, 1 manganese, 1 manganese, 3, this is acetate. Hopefully you remember that from Chemistry 1. That's acetate. So there's 3 acetates. Over here, there's only 1 acetate. So I have to put a 3 right there. And then there's 1 H. Here there are 3 H's. So I need a 3 right there. And then 3 Cl's. There's our 3 Cl's. Okay, so that one is balanced. So it goes 1, 3, 3, 1. Okay, the next one, 1 iron, 2 irons. So I'm going to put a 2 right there. And that makes 2 oxygens plus 2 more. That's 4 oxygens. This side has 3 though. So we need to at least double that. So now we have 4 irons. So let's change that to a 4. And now we have 4 irons, 4 irons. 4 plus 2 is 6 oxygens on the left. And now we have 6 oxygens on the right. That one is balanced. Okay, and our final one, K2CO3, 2 potassiums. I need a 2 right there. Now in this case, notice there's no CO3 on the other side, so we can't use that little trick. So we've got 1 carbon, 3 oxygens, 1 plus 2 more is 3 oxygens, 1 H, 2 H's. So I'm going to put a 2 right there. And then 2 bromines as well, 2 bromines as well. That equation is now balance. Okay, and that is your introduction there to balancing equations, making sure that the number of atoms of each element are the same on both sides.